supposed to be everywhere, and everything is supposed to be made of atoms, then why is it that when I look at this room, I don't see billions and billions and billions of atoms bumping into each other and bumping into me and moving chaotically across the room? Why is it that I don't see the chaos that's everywhere? And the reason is that when you look at the atom, the light you use to see it is much bigger than the size of the atom. It's like a huge water wave passing over a tiny rock. And if you're standing at the beach looking at the water waves reach your feet, you don't see any effect of the small rock that's in the middle of the ocean. That's because it's too small to affect the waves. In the same way, an atom will not affect light waves. Okay, so there is a way to see the chaos of atoms. If I take a tiny little particle and I suspend it in air, and I make sure that there is no wind around, the particle will still be moving around like this in a random chaotic way. And that's because there are millions of atoms randomly bumping into it, kicking it around in different directions all the time. And so in this way we can infer the existence of atoms just by looking at tiny particles suspended in midair. So remember in my example, we had a tiny rock in a huge water wave. What if we took that tiny rock out of the middle of the ocean and put it in a small cup of water and applied to it tiny little water waves? Then in that case, the small rock will be able to affect the water waves and in effect will be seen. What does this mean for atoms? Well, if we use tiny waves, then we will be able to have enough resolution to see the atoms. And in this picture we can see atoms that were imaged by X-rays and also atoms that were imaged by electrons. In the picture, these dots are single atoms and we can make images of them using X-rays and electrons. So what's really more amazing than just being able to see those atoms is being able to grab them and move them around. So in this picture you see the world's smallest movie. It was created by researchers in IBM. It's on YouTube. I left the link in the description if you want to watch it. They made it by moving single atoms around. If you have any more questions, please ask them below, and please subscribe here. And here. Here and here. Here and here.